Hi, in this video we are going to discuss how do we solve a matrix equation. Now this matrix equation here represents a system. We saw how we can represent a system into a matrix equation to be able to solve it. If you don't know how to do that, please go back to our last video. Now we have here a coefficient matrix multiplied by the variable matrix, and that's equal to the constant matrix. If I need to solve that, let's assume this first matrix here is matrix A, and matrix A is multiplied by matrix X, and it's equal to this last matrix, matrix B. Now, how am I supposed to solve that? Think of this as a simple equation. If this is 3x equal to 6, a known matrix multiplied by a variable matrix equal to a constant matrix, known, variable, constant, you will be solving it simply by dividing both sides by 3. Now that would be pretty convenient, and you will get that x is equal to 2. However, I can't do that here because we don't divide by matrices. But what we can do is, instead of dividing by that, we can actually multiply by the reciprocal, and we will get the exact same answer. What we mean by the reciprocal? We mean the multiplicative inverse. If I multiply 3 here by its multiplicative inverse, which is 1 over 3, I will be able to isolate the variable, because 1 over 3 times 3 is 1. And if I do the same to the other side, I will get that x is equal to 2, which is the exact same thing we did a minute ago. Actually, this is a way that we can solve the matrices by. Instead of dividing by a matrix, which we can't do, we can multiply by its multiplicative inverse. How do you find the multiplicative inverse of a matrix? We did explain that in a previous video. We're going to just go through it now together. I'm going to multiply both sides of the equation, of course. Like we multiplied both sides of the equation here by 1 over 3. We're going to multiply both sides of the equation by the inverse of A. So how do I find the inverse of A? Pretty simple. We did it before. We're going to find determinant A, which is going to be 6 minus 4. It's equal to 2. To find the inverse of A, we're going to do half here, 1 over 2, multiplied by, start switching the numbers. So I have 3, 2, and changing the signs, negative 1, negative 4. So the inverse of A is going to be equal to 3 over 2. We're going through this quickly because we already have the details in another video. Negative half, and this is going to be a negative 2 and 1. Now that I have the inverse of matrix A, what I'm going to do is I'm going to multiply both sides of the equation by that inverse, which will make my life very easy, and I will get the solution of this matrix equation in no time. Now remember, order does really make a difference when it comes to matrix multiplication. It's not commutative. So if we are going to multiply by the inverse of A first here in the first side of the equation, we're going to do the same on the other side. So negative half and 1 multiplied by what we already have, which is 2, 1, 4, 3, coefficient matrix, then variable matrix x, y equals, remember, we put inverse of A before A, we're going to put the inverse of A before B also. So if you don't do that, you will have multiple problems. 3 over 2, negative half, negative 2, and 1. Why not after B? Like, why don't we put it after B? It's not only because order matters, which it does, but also because if I don't do that, I won't be even able to multiply. Like if I want the inverse of A after A here and after B here, we can't multiply. In this case, we have a 2 by 2 matrix multiplied by a 2 by 1 matrix, so you can do the multiplication. If I put this on the other side, this is going to be a 2 by 1 multiplied by a 2 by 2. There will be no possible solution. For the details of that, you can go back to our video about the identity matrices and the matrix multiplication. You will get to know why not. Now, if I'm multiplying a matrix by its inverse, we should get an identity. Actually, this is a very good way for you to check if your work in this part, which is finding the inverse, was correct or not. If I multiply 3, we multiply this by this, I should get an identity. 3 by 2 over 2 multiplied by 2, that's a 3, plus negative half multiplied by 4, that is negative 2. 3 plus negative 2 is 1. Then I have negative 2 multiplied by 2, which is negative 4, and 1 multiplied by 4, that's a 4. Together they make a 0. 3 over 2 multiplied by 1 is 3 over 2. Negative half multiplied by 3, that's a negative 3 over 2, that makes a 0. Negative 2 times 1 is negative 2, and 1 times 3 is 3. Negative 2 plus 3, that's a 1. Now this here a way for you to check that your work is correct and you are multiplying by the correct matrix. Now I have this equals to an identity multiplied by x and y, and then the last thing we need to do is multiply these two. Now I'm multiplying a 2 by 2 matrix by a 2 by 1 matrix. My answer is going to be a 2 rows and 1 column. 3 over 2 multiplied by 10, that's going to be a 15. Negative half multiplied by negative 2, that's going to be 1. 1 plus 15, and I have a 16 here. Then negative 2 multiplied by 10, negative 20, and 1 multiplied by negative 2, that's a negative 2, negative 20, and negative 2, that's negative 22. Now I have an identity multiplied by x and y equals to, sorry, I have no more space, 16 and negative 22. I can say now that x is equal to 16, y is equal to negative 22.